This development happens and can be easily or can be traced with fMRI studies. And what you typically see, this is a child and an adult doing math, doing actually the same math task, is you can see that the child at the beginning of doing math has a lot of frontal brain activity. So you have the children or a child that has to concentrate. That's the left hemisphere of the brain. That's the brain from the top. That's the right hemisphere. You have the child that requires a lot of frontal brain activity to understand the task and to perform the task. The frontal brain areas are those areas that you could call multi-purpose areas that can address new tasks, they can do logical thinking, they can do inference, etc. And these are the ones we use for everything we address at beginning, for everything we do new. But over time, our brain automates the things we ask it to do a lot. And this is an adult brain who performs the same math task as the child brain here on the left, but has these specialized brain areas that I just explained on the last slide, with this brain area here automating number line, and this brain area back here automating the Arabic and visual representation of the numbers. And this automation of tasks, also called the functional specializations, leads to the tasks requiring less effort and being solved more quickly. This process, this so-called frontoparietal shift of activities from frontal brain areas to parietal areas, is part of the brain's plasticity. It happens to everything that we ask our brain to do. Also, the piano player I mentioned before will first play the piano with a lot of frontal activity, and the better or the more he practices, the more parietal areas will guide his hands over the keys. So this happens with everything. It happens with driving a car. Anything we do on a daily basis will be automated by the brain in this manner. This requires hundreds, if not thousands, of repetitions. And what I also want to make as a remark is it's not the same as learning something by heart or memorizing. It's really the brain specializing brain areas on performing tasks that we ask it to do regularly. Again, more schematically, you have the brain of an untrained math performer that uses a lot of brain capacity in the front. And then with training, with practice, we have this mainly three brain areas that afterwards automate number words, cardinality number line, and the Arabic numerals. Now, unfortunately, in people with dyscalculia, this specialization of the brain areas at the back is delayed. And it is delayed up to 6 years. Now, you might say 6 years is not so terrible, but if you actually think of a 15-year-old who might get as much automation and support from his brain to do math as a 9-year-old, then a 15-year-old and a 9-year-old, that's really quite dramatic for a 15-year-old to not have more support than maybe a third grader. So on the one hand, these brain areas don't develop as quickly as with people without these difficulties, and also the connection between these brain areas is weaker. So they also have more difficulties to transcode, to go, for example, for me saying 11 to seeing the 1-1 is way more difficult for people with dyscalculia. The reason for this delay in automation, functional specialization, is most likely anxiety. Anxiety in general is a blocker of learning, and in children with dyscalculia, this seems to be the main reason why they do not specialize these brain areas. In particular, it has been found that the amygdala, which is a brain area that controls anxiety, is a lot larger than in dyscalculics, than in the general population, which really means that they're afraid of doing math. And this anxiety, this being afraid of, can block all these automation processes. So that's the problem. These brain areas are delayed in automation, and in some cases might never actually automate. So from all of this, which I presented so far, what should you do? What should you not do? From this observation that anxiety and fear might be the cause of dyscalculia, it's really important that you determine the level of math anxiety if you start working with a child. You have to be aware that this anxiety, this being afraid of, might actually be the cause. And then try to avoid moments and situations where this anxiety is showing or where these children feel anxiety. And if necessary, you really also have to address this anxiety, specifically work on emotions, restore the self-confidence of the children to work on maths without anxiety. What you also have to be aware of if you start working with a child, in particular, maybe in fourth grade, is that with enough frontal capacity and with enough frontal capabilities, also a child that does not automate can be quite capable of performing math tasks on a very good and very high level, maybe up till third or fourth grade.